So today we're going to cover Chapter 6, Section 6, and it's going to cover inequalities in two triangles. So the first slide has our first theorem of this lesson. It's called the hinge theorem. Again, don't memorize the number. And this is a lot of words, but I'm going to simplify it for you. So it says, if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second triangle. So same idea that we just covered in 6.5. Again, we're looking at the angle measures. If one angle is bigger than the other angle, then the side across from that bigger angle will be the bigger side. So what you're looking for is to make sure that you have congruent matches on the sides, and then you compare the angle measures. The bigger angle, the bigger side across from it. Okay, so the converse of the hinge theorem states that if two sides of one triangle are congruent to two sides of another triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So what we're going to be looking for is the congruency marks to figure out which angle in our triangle is the included angle. And then from there, we're going to compare the side lengths that are across from the angle. And when we find the larger side, that's going to determine the larger angle. So the next one, it says, given that D is the midpoint of AC and angle 1 is less than angle 2, what can you deduce? So we're going to use our hinge theorem. So notice I have congruency marks on AD is congruent to DC because they told us D was the midpoint. I also could say that BD is congruent to BD by reflexive. So the two angles that I am comparing are angle 2 here to angle 1. And they told me up at the top that angle 1 is smaller or less than angle 2. So I can deduce that the side that is across from the larger angle, which is 2, is going to be the bigger side. So my larger side is going to be AB is greater than BC because AB is the side across from angle 2, which is the larger angle. If it helps you to add numbers to the angles so you can see it a little bit better, if you recognize that 1 and 2 together are forming a straight angle and they're supplements, you could pick random numbers for angle 1 and 2. Just make sure that the number you plug in for angle 1 is less than angle 2. So I could say that angle 1 is 60 and maybe angle 2 is 120. It really doesn't matter what you put in here. Just make sure that angle 1 is smaller, and then you can tell that BC would be the smaller side. You can also have said here, if you wanted to say it in reverse, say BC is less than AB. Absolutely. So you could have stated the inequality either way. When you're doing the homework, if they already fill in the inequality and they just want you to fill in the letters, just make sure you're seeing which way they face the inequality. Okay, let's try the next one. We're going to use the converse of the hinge theorem on example 2, because notice this time they're giving us side lengths. So in order to figure out, obviously there's only two angles here that are marked, angle 1 and 2, but the way that we would check to see if we could use the converse of the hinge is that this side is congruent to this, and this one is congruent here, reflexive. So now I'm going to compare angle 1. He looks at the side across from him, and then angle 2 will look at its side across. So because 4 is the bigger side, this tells me that angle 1 is the larger angle. So angle 1 is greater than angle 2. And I just use the converse of the hinge theorem. because angle 1 was opposite the side length of 4, and angle 2 was opposite the side length of 3, and because 4 is greater than 3, that's why angle 1 was greater than angle 2. All right, so the next one, this time it wants a range of values. So what I need to do is figure out what k could equal, and I need to figure out which is the bigger angle here. So again, I've got the congruency marks here. I've got one, this side is congruent to this, and then I can show this middle one reflexive. So the two angles I'm comparing here are angle, this one right here, the 38, and it's going to look across at the 19. And then the other angle is this one here, the 5k minus 12, and it's looking at the 18. This tells me that the 38 is across from the bigger side. So 38's the bigger angle. So my first inequality that I'm going to set up to get the high end of the range is going to be 5k minus 12 is going to be less than 38. It's the smaller angle. I'm going to solve for k, and k is less than 50. 5k is less than 50. Divide by 5, and k has to be less than 10. Now, that's as high as it'll get. I need to look at the bottom end of the range because 5k has to be, 5k minus 12 also has to be greater than 0. Because that angle measure, 5k minus 12, is going to be an angle measure between 0 degrees and 38 degrees. So I'm going to add 12. 5k greater than 12, divide by 5, and k has to be greater than 12 over 5. So my range of values, because again, remember, the angle measure is got to be in between 0 degrees and 38 degrees. So this is why I set my two inequalities with the 0 and the 38. So now my k value is got to be greater than 12 over 5, but less than 10. And this is the answer it was looking for. Now, you could also make this a mixed number, or you can leave it improper. So either answer here. So when it wants a range, you've got to use as small as it could be to how great it could be. And that is it for the notes on 6-6, and that is the end of chapter 6.